Okay, it's recording. Okay, before we start, I'm gonna ask the usual questions. Right? You guys know what I asked, right? Like, how many lead code problems did you solve? Right? Yeah, I want to know like who solved more than 25 problems on lead code. On trees, not just lead code. Okay, nobody. Okay. So I want to share like a small story that was super eye-opening for me, and I just came to know about it this week. So an SD2 on my team where I work at Amazon switched an org, and I was talking to him about like how he went about doing that, and he told me a lot of things which I'm not going to share, but he definitely came to the part about interviewing. So even if you want to change a team, there will be an interview, and I asked him like how he prepared. He said he practiced problems on lead code. I'm not kidding. So the moral of the story is that lead code will haunt you for the rest of your life. Like if you want to get into this profession, like you always have to keep your feet wet. So it's not just like a one-time thing. It's not, you're not done with lead code or like interviewing as soon as you get a job, right? If you want to switch a job or if you want to even switch an org internally, you need to get enough practice. So do it. Okay, I'm gonna ask again. How many problems on trees did you guys solve on lead code?
I haven't done any after this class.
Okay, so do it. Yeah. And yeah. About today's class, it's DP. And DP is like the hardest topic that they can come up with in an interview. And I have like problems listed, but I'll be like very glad if we can get them with half the problems, because every problem is going to take a lot of time to just explain and solve and understand the solution. So let's see how far we can go, and I'll think about which problems I want to solve as we go along today. Okay? Okay. Let me quickly open up Paint. Screw you. This is like as easy as it can get, so I didn't want to scare you like right in the beginning, so I started off with an easy problem. Yeah, read it. I'm just gonna make sure the camera's okay. Yeah, I need to make the font bigger. Okay, let's stick with 175. Any ideas?
I think I've seen this before.
Yeah.
So while we iterate through the array,
Yeah.
we should try to find the first minimum value that is
Yeah.
coming, and then sell at the, okay, so it's like a curve.
Yeah.
So when you see a dip, you
Yeah.
buy,
Yeah.
and when you see a rise,
Yeah.
you sell. And again when you see a dip, you buy, and again when you see a rise, you sell. That's how we can make the maximum profit.
Correct. What you're saying makes sense, but there is a price at which you bought it and there is a price at which you sold it, right? And that difference has to be maximum.
Yeah.
Yeah. So will you be selling it at the same price throughout the array or buying it at the same price throughout the array?
I didn't get that.
So you said you have to see a dip and a rise. So dip and a rise is just depending on these values, right? Or their
Yeah.
differences.
They should be. I forgot that.
Yeah. So basically this question is asking you to find like the maximum profit. So it's very tempting to solve it like this, right? You make one sweep through the array, find the minimum, make another sweep through the array, find the maximum, and then that difference is definitely going to be like the absolute maximum, right? That's what you want, right? the maximum difference you can get between any two values in the array. And I'm going to sell it on the day, or I'm going to buy it on the day when it's minimum, and I'm going to sell it on the day when it's maximum, and then I make the maximum profit that way.
Yeah, the problem happens when
Yeah.
if the array is like 716,
Yeah.
345, for example.
Yeah, then
716.
even if it's 716, I sell it at 6 and buy it at 5.
But again, you should buy at 3 and then sell at 5. You get a
No, I just want to make one transaction.
Oh, just one. Okay, that is problem, a next level problem.
Yeah.
Okay.
Yeah, we are not even there. We're just solving the most basic.
Okay. Just one transaction.
Version.
That's it. Just win.
Yeah. Yeah, min and max. So that's it. That works. Is everybody following what I'm describing?
We don't find
So okay, right now it will work, right? What is the minimum here?
it depends on
It's
the
one,
order
yeah.
of the array. I mean,
Yeah,
whatever-
it depends, because if the max is one day before the minimum,
Exactly.
then
then
you
it's
can't
not the
Yeah.
max.
that won't work.
Yeah, that won't work
Yeah.
because the min can happen after the max,
Yeah.
and then that will like break your calculation, right? So what do you guys propose then?
Running minimum and running maximum, but
Yeah.
once we see it.
What is that? Could you define running?
Running
minimum?
minimum in the sense, try to initialize one as the minimum value
Yeah.
and then compare every value with that and
Okay.
then have a minimum.
Yeah.
Similar to that, I mean, when we see an element that is wait, I'm ready for it.
Yeah. So she's very close. So running minimum means the minimum that I encountered so far. So running minimum could change. Okay. So when I get to like the value where like theoretically, like let's say the answer is like here and here, right? I buy it here and sell it here. Then when I get to here, what do I need to know?
The minimum that is found so far.
So far, exactly. So beyond that, I could find another minimum which is less than the minimum here, and another value that is greater than whatever is here, and that will be the days on which I make the most profit, right? So at every point, all I need to know is what is the minimum I've seen so far, and then what do I do? But
Difference of
yeah,
and if, I mean, we can take a running max difference as well.
yeah,
Like when we see 7 would be the minimum.
Yeah.
So we initialize 7 as minimum.
yeah,
And when we go to 1 is minimum. When we go to 5, the difference between minimum and that is 4. So we
Yeah.
can make the difference as 4.
and why won't you make 5 the new minimum? Because when do you get a new minimum?
Only when I mean, it is lesser than 1, right?
Yeah, only if I encounter a value that is less than my running minimum.
Running, yeah.
Then that new value becomes the new minimum, right? Yeah, that's it. And so basically, like in an interview, all they care about is runtime, and so you can solve this problem using DP, but you can solve it in a better way without DP. But since today's topic is DP, I'll just show you how to solve it with DP. Let's look at the solution for this. Okay, does anybody here not know what is DP, dynamic programming? Okay, so do you want to define what is dynamic programming?
I think dynamic programming is when you try to solve the sub-problems of a problem first and use those solutions to find
Yeah,
the solution to the bigger problem.
so that's recursion, right?
But yeah, I mean, if it's not
Recursion,
recursion, then you
Yeah.
store the
Optimal substructure or overlapping subproblems.
Okay, that's getting very technical.
Otherwise, it's recursion only. But yes, like if we don't save it, then it is unnecessarily recursion again and again and again.
Yeah,
the runtime
correct.
will be too much. That's why we use TP, that we save the subproblem.
Awesome.
Yeah, when we try to minimize an exponential
Yeah.
and then to the
Yeah,
order
good.
of n.
Because that problem can be solved by recursion, but that would be too expensive.
Exactly.
Yeah.
So dynamic programming is basically problems that you can solve with recursion, but you could be calling the same recursion multiple times. And the way to avoid that is to save the result of some recursion that you already calculated somewhere, so that you can just refer to that. over and over again. Actually, there are many definitions, like whatever I just described is not the strict definition. You can also solve a problem using dynamic programming in a bottom-up way, where you're trying to calculate and store the results of solving the subproblems first. So in a recursion, what you do is you're supposed to solve, you're supposed to return the answer for a function for a certain input, and then that calls the same function on a smaller value of the input.
That's
right?
Memoization, right? Trying to see
Yeah.
whether you've already solved it and then progress.
Yeah, whatever I described is memoization, but if you do bottom up, you already know that you're going to encounter a smaller version, so you start off by solving the smaller version and then you store them. I think that's what we do here. So as I go along this array, at every point I'm going to have a helper array, and in the helper array is going to be the same size as the input, and for each index I'm going to have the value of the max profit that I can get at that index. And once I build that array, I can make a sweep for that array. So that array is basically an array of profits that I can make. So I'm going to sweep that array and get the maximum, right? Okay. Okay, hang on. Okay, this is a fail. So here, instead of using an array, I used a temp min. So okay, let me code this up, right? Just to show you how to use an array. Or no, like today's class is going to be really long, so I don't want to code something that's very trivial. Okay, so typically I would create another array the same size as prices, and then use that to store the profits that I've encountered so far. But the thing about this problem is I don't need all of the values that I put in the array so far to calculate the current value. So all I need is just one value. And with that one value, I can get the difference with the current guy, and then I update this max profit variable, store the maximum profit I encountered so far. So basically I did this very cleverly without BP, and that's what I have here. So this is not dynamic programming. But I just want you to look at this solution and solve it in a DP way yourself. But let me know if there's something you don't get.
I have one
Yeah.
strategy question.
Yeah.
Whenever we try to find the running min or running max, we'll use this integer.max and integer.min.
Yeah.
But that doesn't work all. Sometimes we need to initialize it as 0.
Okay.
That has happened. I mean, how to judge what should be the initializing value for a max?
Yeah, so the most intuitive initializing value is 0, but sometimes 0 will not work because let's say here I do math, let's say instead of math.max I'm doing math.min, right? And if I make my max profit as 0, then math.min, then 0 will always win over some positive number, right? So in that case you will not get the correct answer. So the point of using math.min is that any value is greater than it. So the first time I hit math.max, max profit will become this guy. Unless this guy is also math.min, but they won't test your problem on cases like that. If they're doing that, then there is a workaround. You can just make this guy as long.
Okay.
Okay. Did everybody get our question? Yeah. And my answer? Okay. Okay, so this is very trivial, right? Does this make sense to everybody? So you just have one running tenth minimum, running minimum, and I have a max profit, and I update my running minimum if I get a value that's less than what I currently have. And I make this guy integer.max value because the first time I see any value, temp minimum is going to be that guy, and that's what I want to happen, right? And max profit will just be the difference of what I'm looking at right now and the minimum I've encountered so far, and I just store that in max profit. Yeah.
How to solve this?
Sorry, 2 questions. So okay, go ahead. No, you go ahead. You had a question, right? Meow.
Oh, yes.
Yeah.
I also have a question. How do you make sure the price I is behind the temporary mean?
Because we go from 0 to or like.
I think this for loop is to check which is the mean,
Yeah.
and then the max profit. I think the max profit should be the price I should be behind the mean.
What do you mean behind? Should the index of price be greater than temp min? Well, I don't. What's behind you is forward to me. So just tell me, like mathematically.
Let's look at the example that the recorded.
Okay.
The first one is 7 and the second one is 1, right?
Yeah. So. Yeah.
But the 7 and 1 is
Yeah.
not suitable for the topic.
Yeah.
Because you should buy in 1 and then sell in behind 1.
Yeah. So what happens is I have that check, right? Temp min less than prices of A before I update max profit. So when I get to 1, I would have set temp min to 1, and then I will compute the profit.
Yeah. I
At
think
that point-
in the for loop
Yeah.
you found 1, right?
Yeah.
And then in the max profit
Yeah.
you will
I will have
you
0.
find the most big difference.
Yeah. At this point, it's 0, right? The biggest difference that I can get is 0 because if I bought it here and sell it here, I'm running into losses.
Oh.
So if you get into a situation where you're running into a loss, you update 0 as you set 0 as the max profit. Yeah, I think we should move on. I'll talk to you about this later. It's very trivial. Okay?
Okay.
Sorry about that. I would have totally covered it, but this problem, the way I solved it is not DP. It's just an oversight. Sorry about that.
Yeah. So
Yeah.
the question was like, how do you come up with the substructure for this problem?
Yeah, it's so the recursion in
Because
this
I think
is
if you are going to use DP, it's going to be n-square solution.
yeah, exactly. So it's an oversight. I just added it in there. Yeah, you can do it with DP more inefficiently, but it's pointless to talk about DP in this case.
Yeah,
let's
just
let's
curious.
move on and do
Yeah.
more interesting stuff. Okay, sorry. Okay, I like this. Okay, so one caveat is that this problem can be solved again. This problem can be solved in a better way without DP, but you need to know like some math theorems. So in this problem, in this case, it makes sense to look at the worst DP solution because the actual mathematical solution it's like O of log n, but it requires like a lot, like an in-depth knowledge of math. So yeah, let's do this with DP.
In general, there are many trick questions.
Yeah, but they won't expect you to like solve this with that math trick.
Okay, in general, I mean, not even like in-depth mathematical knowledge, even the basics like taking a log will work,
Yeah.
using sine cos will work. But will they expect these kind of answers from us?
I don't know. I
Discrete
think it depends on the role.
Okay,
Yeah, depends on the role you're interviewing for.
okay.
Yeah, and this happened to me once. So in my Google interview, I proposed a mathematical solution, and they were like, "No, I want you to use DP," and show it to me. Yeah. So even if they do, I think it depends on the role. They will insist that you do DP if it's for an ST role. Okay. Okay, so I'll move to paint to explain this problem. So basically you have a number n, which could be anything, like tell me a number. 20, okay. So I can sum up 20 in many ways, right? So one is 1 plus 1, 20 times, right? Yeah. So I just want to explain the question. So I can do 2 plus 19 ones or 18 ones, right? Yeah. So I can have like many combinations like this, and for each of these I can multiply the numbers that I get that I'm adding, and I get a product, right? I want to output the product that will maximize. I just want to output the maximum product that I can get by multiplying those numbers that add up to the n. Okay? Does that make sense? So here the product would be 1. Here the product would be 2. I can just do 10 plus 10. Here the product would be 100. Okay, this is wrong. 1 plus 1 so many times is not 1. It's just it's the product. Right? So I just need to output like the maximum value that I can get. So, okay, does anybody want to tell me why n can't be larger than 58? Why they put that condition?
Maybe the product.
Just by whatever we just did.
Return type with integer maybe that.
Mm-hmm.
It doesn't fit in that.
Yeah, why only 58? I mean, you're right, but why 58
The
for
product of that
integer?
number, like whatever sum which we get from 58, if you product those numbers, maybe that is not going to fit into integer or long, whatever that is.
Yeah, so I can break 58 into how many twos?
27, 29.
29 twos, right? And what is the maximum value I can fit in an integer? What is the maximum positive value?
31
Yeah, 2 power 31
minus 1.
minus 1, right? So 2 power 29, and if they do 59 or anything more, it'll overflow. It'll go beyond that. So that's why they chose 58. So yeah, that's kind of like a hint on how you would solve this problem. So how would you solve this? So okay, for this problem, like this is real deeply. So think about like recursion. Think about if I had the answer to a smaller version of this problem, how would I use that to get the correct answer for this version?
So at each point, we will have to find, for example, for 2,
Yeah.
using the number 2 itself, what is the product?
Yeah.
Or using the number 1 twice, what is the product?
Yeah, for 2 you can't do 2 plus 0, so you can't do 0, so the minimum is 1.
Walking we can take numbers from 1 to 58
Yeah,
and then subtract each number from 58
Yeah.
and then take do the recursion on
Awesome.
whatever.
yeah. Did people hear that? So let's say n is 36, okay? I need to find how I can break 36 such that I can get like the biggest product that I can get, right? So that means you write 36 as sum of many things, right? And the last guy is also like a finite integer, right? So the last guy could be a 1 or a 2. Let's say okay, let's just do 10. Just for simplicity. So if n is 10, the correct answer is 3 plus 3 plus 4, right? But 10 can be written as like sum of some numbers plus 1, sum of some numbers plus 2, so on, right?
We need to take a max out of all these possible solutions, right?
Yeah, exactly. No, the max of the product
Product of all these
this
solutions.
and whatever output apart. So what will the sum of this be? If
This is 10.
yeah, if n is 10, then this should be 9, right?
Yeah.
Yeah. And if this last guy is 2, this should be 8, right? So if I know what is the answer for 8, then what will be the answer for 10 if I break it this way?
8 into 2, whatever the value of the product will get into 2.
Not 8 into 2.
Like whatever however you
Yeah,
take maximum
yeah.
value in that
Yeah.
into 2.
Yeah. So basically I have an array, and for each index of the array, I'm solving this problem for that value. Right? So let's say I have an array of size 10, then that index 0 will be for value 1. Index 1 will be for value 2. It will have the number that is basically the max product of like breaking it into like parts that sum to 2. So on. It's hard to define this problem, so in one sentence. So you know what I'm talking about, right? So f, let's call this function as f. So f of each index I will be, sorry, the value at index I will be f of I plus 1. Right? So that means the max product that you can get by breaking it into parts. Right? So for computing the value for n, it will help to know all the values before it. what is the value for it? What is the output of calling that function on n minus 1, n minus 2, so on, right? And for n minus 1, I would need everything before it. For n minus 2, I would need everything before it. So if I start with 0, or basically value 1, I can start building. Does that make sense at all?
I understand that we have to find all the numbers before that number.
Yeah.
But I'm just confused as to how do we take the max. For example, how.
Yeah. Okay. So for DP, before you actually click start coding, you need to in a pseudocode kind of way, you need to write the recursion, and then you need to come up with a good data structure where you can store values, and you need to see how you can compute this recursion from the values you stored in that data structure. Okay. So for here, okay, first of all, what is the recursion here? So let's say I need to find f of 1, f of n, right?
It should be some max of.
Yeah, good. Max of what?
It should be f of 1 plus f of n minus 1 comma f of 2 plus
So you
f of
get-
n minus.
Why is it plus?
I mean the product s
Yeah.
will give the product.
So we take some j,
Yeah,
j into
Into-
whatever the f
into.
of n minus j.
yeah, exactly. Yeah,
Into f.
yeah,
Set sum.
correct. So for I equals, you don't have 0 because 0. If you have 0, then
Multiplication
yeah, the
becomes
product
0.
will become 0. So I start at 1, and what is the limit?
N minus 1.
No, if I have n, okay, let's think about this limit later. So the recursion will be max of, so inside the max I have the for loop. So it will be the max of I times f of n minus I. Right? Because what is I plus n minus I? It's n, right? So basically I break this n into I plus some other way where they would have broken n minus I, but that product would have been maximum, right? And the current product will just be I times that, right? So this is my recursion. So if I goes all the way to n, then again you get f of 0.
Yeah.
So it's just n minus 1. So what's a good data structure to store these values? Array, because all I need is f of n minus I, right, for each n.
A single dimension.
Yeah, 1D array, exactly. So, yeah, that's it. So, let's take a look at the solution. I hope I solved it the DP way. Please. Oh, okay, I solved it the DP way. Okay. Yeah, I don't know, maybe I just read it and left it. Usually if there's like multiple ways of solving problems, I solve it in all the ways, but anyway, good for us. So, yeah, so these are the base cases. Why did I do 3?
I mean for 3 maybe the max
Max
is.
product is 3.
Product is 3, is it?
It's
It shouldn't be 3, right?
Yeah, it's not a big deal.
3 into 1.
Yeah, this is.
It should be 2 into 1.
Yeah, I think, okay, my bad. Yeah. So, breaks of 1 is f of 2,
Oh, okay.
and breaks of 0 is f of 1. Yeah.
Okay.
So, for 1, for 0 it will be 1. Did I set that anywhere? No, okay. So, if n is 1, I directly return 1. If n is 2, also it's 1. Yeah. Yeah, some of this could be redundant, but.
Only I mean it stands good for till how many integers?
50,
Only till 4 is it?
58.
I mean no, the base cases
Yeah.
till how?
Yeah,
how
base
many
case till
integers?
n is 4.
What happens in
What's the
5?
array break?
No, yeah. Sorry?
So breaks is going to stay the product up to that
Yeah.
limit.
Yeah, so breaks of I is basically integer break of I. So the function is, so the problem asks you to return the value of that function, whatever the description for n, right? So I compute the same function for all values less than n. And I store it into the array because those are the values I need, right? So this recursion is same as whatever I wrote in paint. I to I minus j, but I do that for every I. So that's why it's I minus j, it's not n minus j.
I think it is, I mean, it starts from 4, right? So I think the answer for 1 is 1, the answer for
Yeah.
2 is 2, and
Yeah.
the answer for 3 is 3.
No, the answer for 1 is 1.
Huh.
The answer for the answer for 1 is 0. Yes, yes. That's why I did not initialize it. The answer for 1 is 0 because you can't break 1 as something plus 1.
But you have returned 1.
Yeah, I think they had like a weird. Yeah. The answer for 1 is 1. Yeah, because even though you can't write it as something plus something, there are no pluses there, but it's just 1, so you just return that. I mean, it's kind of ambiguous, right? In that
Yeah.
case,
Ah.
so they just went with 1. But for 2, it's 1 because
Yeah.
2 plus 0 is 0, right?
Yeah.
So for 2 it's 1. So yeah, breaks of 1 is actually f of 2, or integer break of 2, right?
But for 4,
Yeah. Yeah.
it should be 2 into 2.
Yeah,
right?
for 4 it will be 3 plus 1.
2 into 2, right?
Yeah, right. Hang on. This is
That's why, I mean, you have started
Okay, yeah.
the array from
For-
4 and you have returned it as breaks of n.
Yeah, one second. So n plus 1. Yeah, I think for every integer I return what I'm supposed to. But right. Yeah, now I remember. Yeah. So the thing is, these are the answers that I'm supposed to return for those values.
Yeah.
But if I put those values in the arrays, the answer will be wrong.
Oh,
If I use those base case values.
okay.
So technically speaking, I should have like 1, 1, and 2 here.
Ah.
But that's going to screw up the computation for the future ones.
Yeah, because we are not considering.
But how-
Because we don't consider the integer itself.
Yeah.
We don't consider the case where it's the integer itself, because that will not give us the max value. Actually, I don't know, they're weird. For 1, they are accepting 1 as an answer, but for 2, they're not accepting 2 as an answer, because 2 can be written as something plus something, and that product is positive. So, yeah, that's why it happens.
Okay.
Yeah, that's where it breaks all that. So if it's 4, it'll go through all this calculation.
Okay, how did you figure out these 3 base cases? Because they are kind of tricky. The array initialization.
Yeah, I figured out this base case because I was failing test cases already. I tried to work it out and then I came up with this. Yeah, nothing genius going on there. Does this make sense?
Actually, on breaks of 3 is 3. I still didn't get it.
Yeah, so breaks of 3 is 3, but
Maybe
if
it's
n was 3, I
random.
would not return 3. If n was 3, I would return 2,
Yeah, you return
right?
2. Yeah.
Yeah,
Then
but
why
the
did
thing
you
is,
say 3?
yeah, why I did it is, let's say I want to get breaks of 4 now.
Breaks of 3 is 3, right?
Yeah, that's what I have.
You
Breaks
can
of
run
3 is
one
3.
example where we use 3 too. Then we might get to
Yeah, I'm thinking about that. For 4,
The 10 doesn't, oh, it's
yeah, for the
3.
breaks of 3,